Hello my friends, and welcome to the final section of part 3 classification, where we're going to answer together a very important question, one of the most frequently asked questions in the data science community, which is, which classification model should I select, should I choose for my data set? And the goal of this tutorial, because we'll try to make it in one tutorial, is to show you how with any data set, regardless of the number of features you have in the data set, well, I will show you how to select quickly and efficiently the best classification model. All right, so that's why here we're back into our machine learning A to Z model selection folder, which is a separate folder compared to the whole machine learning A to Z folder with all the codes and data sets. And I gave you the link to this folder right before this tutorial in the article, so make sure not to miss it, and mostly make sure to click that link and also download that folder by clicking the zip folder given at the bottom of the same article. All right, and so now after downloading the zip folder and clicking the link to this Google Drive folder, we should all be on the same page to figure out how we're going to select the best classification model. All right, so here we are in the classification folder of our model selection big folder. And as you can recognize, in this folder we have all the classification models that we implemented together all along this part 3. You have all of them, however, I slightly modified them, but the only thing I did, with respect to what we did before, is that I removed all the print, to alleviate or lighten the implementation so that we can see more clearly. And also, of course, at the end, I removed the 2 cells where we visualize the training set and test set results, right? Because remember, these visualizations only work when you have 2 features. And here, as you can see, I took a classic data set with many features. You can see all of them here. So these are all the features and this is the dependent variable. But you can see this data set as a generic data set containing many features, all with numerical values, right? We won't do any kind of specific data preprocessing, and indeed a binary dependent variable taking values 2 or 4. All right, so since we have the data set in front of us, well, let me explain what this is about, even if, it doesn't really matter, because the goal of this tutorial is just to explain how to deploy efficiently all your classification models and quickly figure out what is the best one on any data set, regardless of the number of features. But let me still explain what this is about. So this is a classic dataset which belongs to the UCI machine learning repository and which is about breast cancer. So in this dataset, each row corresponds to a patient, different patients here. And for each of these patients, we gathered, well, first the sample code number, the clump thickness, the uniformity of cell size, the uniformity of cell shape, the marginal adhesion, the single epithelial cell, the bare nuclei, the bland chromatin, the normal nuclei, and the mitosis, okay? And all these variables are the features, from sample code number, even if that's not really a feature, up to mitosis. And with all these features, we are predicting the class, which tells for each patient if the tuner is benign, in which case class takes the value of 2, or malignant, in which case class takes the value of 4. All right, so that's what the dataset is about. You can find it on the UCI ML repository by the name breast cancer, and you can take the original version. But really, don't worry about all these features because, most of us don't understand what they mean. We're not doctors here, but we are data scientists. And even if we don't understand the domain knowledge here of oncology, cancer medicine, well, that's still fine because we can still build classification models to understand the correlations between all these features here and the dependent variable class which we want to predict, telling if the tumor of each of these patients is benign or malignant. All right? And so we're going to use this data set to deploy all our classification models in a flashlight, in a matter of seconds, and after just a few clicks, we will be able to figure out what is the best classification model for this dataset. All right? Great, so let's do this. Let's close this. And now what we're going to do in order to start the demo is, because this is a Google Drive folder to which all of you have access, and therefore you can't modify it, obviously. And so what you have to do in order to modify these cells, because we will have to enter the name of the dataset because these are all code templates. In order to modify these cells, you need to create a copy. So that's the first thing we'll do here, let's do this quickly, you know. You just need to do a right click and then make a copy for each of them. All right. Then kernel SVM, make a copy, logistic regression. So you see it's pretty fast. Sorry about that, but at least it only takes a few seconds and then you get all your copies in case you know you want to modify them, but I recommend to. All right, then your copies would go naturally to your main drive or, you know, in the Colab notebooks folder. Here they just went into my drive, so all good. Now we're gonna open them all. So starting with the last one, random forest. All right, then we're gonna open decision tree classification, open. All right, you can open it with Jupyter Notebook also if you want. All right, then we're gonna open naive Bayes. All right, then we're gonna open kernel SVM, perfect. Then we're gonna open SVM, where is it? Right here, support vector machine, open. Then we're gonna open the k-nearest neighbors. All right, and finally, we're gonna open logistic regression. I went from the last to the first because as you can see, this is the way now we have all the files in the correct order. All right, great. So now they're all copies, therefore we can modify them. Let me just show you once again how I modified the original classification codes we made before to these new ones, you know, more simplified ones, which will get you the accuracy quickly and efficiently. So the data preprocessing phase I kept exactly the same, including, you know, the feature scaling applied to xtrain and xtest. But here I put a template name and I highlighted that you have to enter the name of your dataset here. So that's what we'll do, I'll show you. But that's the only thing that was changed. Indeed, we don't have to do much else because this will automatically select all the features and not your dependent variable. And this will automatically select your dependent variable. And that provided, of course, you have in your dataset first the features, you know, in the first columns, and last the dependent variable in the last column, right? Make sure of this. What we're gonna do now works for any data sets regardless of the number of features, as long as they have the features in the first columns and the dependent variable in the last column. Make sure to remember this. All right, and then all good here. If you want, you can change that from 0.25 to 0.2, but that's fine. Both values work well. Then feature scaling. All right, then for each of the classification model, I kept, you know, the code to implement and train it. And finally, what I did in the last cells is simply I removed, you know, the prints that displayed the vector predictions and the vector real results next to each other because, you know, we don't really need it for our model selection process. However, what I did is that I kept this, of course, but in order to compute the confusion matrix and the accuracy, I had to create that ypred vector containing all the predictions by calling the predict method applied to xtest from our classifier. And that's all I did. And I did the same in all the different files, right? K-nearest neighbors, data preprocessing phase, training and confusion matrix. Same support vector machine, data preprocessing, training and confusion matrix. Then kernel SVM, same, data preprocessing phase, training and confusion matrix. Naive Bayes, data preprocessing phase, training and confusion matrix. And decision tree classification, data preprocessing phase, training, confusion matrix, and finally random forest, data preprocessing phase, training, and confusion matrix. See? So you have the exact same code templates for each of the classification models we built together. The only thing that changed is actually this cell, because this cell actually builds and trains the classification model you want to try through this model selection process. All right? Perfect. So now we're getting very close to the demo. And so just to recap, this demo works for any data set, regardless of the number of features, and as long as you have your features in the first columns and your dependent variable in the last column, and also as long as you don't have some special data preprocessing tools to use on your dataset. If you have any categorical variables, you know, in strings or categorical variables where you have to perform one hot encoding, well, don't forget to use your data preprocessing toolkit to preprocess the right way your dataset. And then you can just deploy all your classification code templates here, and that, my friends, is exactly what I'm about to show you right now. So now the demo is going to start. Are you ready? 3, 2, 1, go. All right, so I'm going to do this as efficiently as I can in order to show you the power of code templates. So the first step is to upload the dataset inside the notebook. Right now it is connecting to runtime to enable file browsing. Actually, I'm going to do this for each of the models here because, it always takes a few seconds. So let's do it this way to be efficient. All right, so I'm just, loading all the files here. All right, perfect. And everything, every file is now connecting to a runtime. Now be careful. If you don't see the sample data here, you have to refresh. Otherwise, you will have issues uploading your dataset. Good, now it's good. So then next step, we upload the dataset. All right, so this is the model selection folder, and more precisely the classification folder. But let me show you the path again. I put this machine learning model selection folder into my desktop, but make sure to find it on your machine wherever it is. If you have not downloaded that already, make sure to download it right before this tutorial in the article. You will find the link at the bottom of the article. Then together we're going to go inside, then inside classification, and there we go, we select data.csv. Then we click open, then we press OK, and then what we simply need to do inside this code template is just to put here the name of the dataset. So you just double click this and then enter data.csv, or the name of your future dataset. All right, and that's it. That's all we have to do in each code template. Only one thing to change so that we can really call it a code template. All right, great. So now we're going to do the same in each other implementation. So now k nearest neighbors, let's refresh this because we need to see this. There we go. Then upload, then data.csv, then open. All right, perfect. Okay. And then we replace here the name by data.csv. Perfect. Then next one, support vector machine, refresh, upload, then data.csv, then open, and perfect, we have the dataset. Now we replace this by data.csv, and all good, SVM is ready. Now kernel SVM, refresh, upload, data.csv, open, okay, replacing this by data.csv or the name of your future dataset, and there we go, kernel SVM is ready. All right, then naive Bayes, refresh, upload, data.csv, open, okay, and then replacing this by data.csv. I hope you appreciate how this is a very efficient process. Naive Bayes is ready, so now let's move on to decision tree classification, and there you go. So that happens when you have too many sessions opened on Google Colab. I left it on purpose because I'm sure you will also encounter this situation. And what to do in this situation? Well, no worries at all. That's very simple. Since Google Colab actually allows only maximum 5 sessions to run at the same time, well, what we'll just do here is that for decision tree classification and random forest, because here that's the same, well, we'll just close them for now. All right, and we'll reopen them after we get the best accuracy from these 5 models, okay? So we'll get the best from these 5, then we'll run the last 2 ones, decision tree classification and random forest classification, and we'll see which one wins, which one is the big winner, all right? So now all our implementations are ready. So, of course, the next natural step now is to run all these cells to get all the accuracies of these 5 models. All right, so let's start with logistic regression. Are you ready? Let's click runtime and then run all. And all the cells will be running and we shouldn't get any error. Indeed. And we get, wow, we start with a very good accuracy because we get an accuracy close to 95% for logistic regression. All right, and indeed we only have 4 plus 5 equals 9 errors, 9 incorrect predictions. Wow, pretty good. So let's see what we get with the next ones, And it's really reassuring that we get these high accuracies because we are doing predictions for breast cancer. So we really want to, be accurate on predicting if patients have a benign or malignant tumor. Okay, so let's hope that we can do even better than this. All right, so I'm going to scroll back up. Oh no, actually I'm going to leave that here in case we forget. So 0.947. Now let's move on to k nearest neighbors. Let's click runtime here, then run all. And there we go, my friends. We're about to get the next accuracy, which is exactly the same one. I just checked that, I put the right model here, but we have exactly the same one actually, which, can totally happen because you just have to make 9 incorrect predictions. 2 classification models can make the same number of incorrect predictions, and therefore you will end up with the exact same accuracy. So that's very interesting, actually. This is the first time I observed this. All right, so, well, let's still hope we can beat this with our next classification models. So now with support vector machine, we're going to click runtime and we're going to click run all to see that next accuracy we're getting. And all right, interesting, this time we get a lower accuracy, but still a very, very good one. And, that makes me very excited to see what kernel SVM is going to do, with a nonlinear kernel. Because indeed here we get 10 incorrect predictions as opposed to 9 incorrect predictions before with logistic regression and k-nearest neighbors. But here with SVM, it's still very, very good. We get 94% accuracy. All right, and now let's try kernel SVM. I look forward to seeing what we're going to get. So let's click runtime and let's click run all. And the accuracy is, yes, we beat it. 95%, 95.3%. That's excellent, and that was actually expected. Kernel SVM, is really, really good. You will get good results with this because, we get flexibility on the curve to catch the correct predictions. All right, so very, very good, but we still have 3 other classification models. Let's see what we're going to get with them, starting with naive Bayes. All right, so let's click runtime and then run all, and the next accuracy is, okay, so like SVM, 10 incorrect predictions resulting in an accuracy of 94%. All right, that's okay. And now, well, we still have 2 more chances, one with decision tree classification and the other one with random forest classification. So now what we're going to do is we're going to click runtime here, then manage sessions. Then we're going to terminate all these sessions here because, we're only allowed to run maximum 5 sessions at the same time. So I terminated all of them. You can close it now. And we still keep the accuracy, so that's totally fine, right? We keep the accuracy everywhere here, so we can totally compare with our last 2. So let's do this. Let's open first, random forest classification because, it gives them in that order. Well, actually, that doesn't really matter here. But anyway, let's open decision tree classification now. All right. And here we go. We have our last 2 models. I can't wait to try them because I can't wait to see who is going to be the big winner and if we can beat even more that best accuracy of 95.3%. All right, so next step is not to click runtime here because remember, we haven't uploaded yet the dataset into the notebook. So no need for refresh here, all good. Upload, then data.csv, open. Then let's do quickly the same for random forest classification, but first, let's not forget to replace this by data.csv. All good. Now random forest classification, little folder here, connecting to runtime to enable file browsing. Okay, so we just have to wait a few seconds here. There we go. No need to refresh. Then upload, then data.csv, open, then OK, and then let's replace this by data.csv. All right, and now, my friends, we're about to reveal the final podium, the 3 best models with the 3 highest accuracies. So let's do this, starting with decision tree classification. So let's click runtime here, run all, and now, there we go. Wow, that's incredible. We actually beat the accuracy. I really didn't expect this. Usually, decision tree classification is not the winner, but here we have a beautiful exception to the rule. Indeed, we get a beautiful accuracy of almost 96%, 95.9. It beats by very little, the accuracy of the kernel SVM. The kernel SVM did 8 incorrect predictions, 5 plus 3, and the decision tree classification did 4 plus 3, 7 incorrect predictions, resulting in having an accuracy almost equal to 96%. Wow, that's really, really good. This is the first time actually that I'm doing this, trying this breast cancer dataset with you, with all these models. I tried it once with logistic regression in another course, but this is the first time that I implement all these models and deploy them to do a model selection process on this dataset. So that shows you how I'm confident about these code templates. I never tried them before on this dataset, and I'm making this demo with you for the first time on this dataset. All right, so therefore the excitement. And now, final one. I'm very curious to see if we can still beat it with random forest classification. So let's do this. Run all, and the final accuracy is, whoa. Oh, all right, okay, so very disappointing. The random forest classification indeed really messed up with the teamwork, and that's another exception to the rule because, usually teamwork is better than individual work. But no, we had a very powerful decision tree classification model before, and it didn't need anybody else to be performant. All right, so that's very interesting actually. This is very surprising results, but that's why it's really, really important to try all your models and have these very efficient code templates that allow you to do a quick and efficient model selection process to quickly figure out the best model. All right, you have to understand that there is no rule of thumbs, and for some other data sets with other machine learning problems, the best model will be another one of these 5 models. All right, so it was really important for me to show you this and to give you this. Okay, so now there we go, my friends. We are at the end of part 3 classification. Big congratulations to you for, well, completing this part 3 and making such a good progress on this course. Now in the next part, we will start clustering, which will be our first unsupervised model. I remind that the difference between supervised and unsupervised is that with supervised learning, you know what to predict, you know which dependent variable to predict, and with unsupervised learning, you don't know what to predict, and you will actually have to find some patterns in the data to figure out something you could predict as a dependent variable, but that you don't have a priori and that you create a posteriori. All right, so no worries, we will see all this in the next part. And until then, I think you deserve a good break now. So get some good rest, relax a bit. And as soon as you're packed up back with some great energy, well, join us in the next part to tackle clustering. And until then, enjoy machine learning.